The overall goal of this experiment is to characterize diffusional motion of topological polymers, especially cyclic polymers, under entangled conditions at the single molecule level.
This method can help answer key questions in the field of polymer physics, such as topology-dependent space-temporal dynamics of polymers. The main advantage of this technique is that heterogeneous diffusion can be quantitatively characterized at the single chain level, which is usually hidden behind ensemble averaging.
To begin this procedure, dissolve perylene diamide salt in 150 milliliters of water. Then, dissolve monofunctional poly-THF in 4 milliliters of acetone. Add the acetone solution dropwise to the vigorously stirred aqueous solution. Collect the formed precipitate by vacuum filtration. Next, prepare a 5 mg per milliliter solution of the precipitate in toluene. Reflux the solution for 4 hours. After allowing the solution to cool, completely remove the solvent under reduced pressure by rotary evaporation. When finished, dissolve the residue in a 2:1 mixture of N-hexane and acetone and filter the resulting solution through a plug of silica gel. Then, add the filtered solution to ice-cooled water to precipitate the product.